Okay, good morning. So let us continue the lesson. Let me just review a little bit. So, do you remember last time we wanted to talk about differential equations of these four? Let me review a little bit more. So, we first talked about differential equations in general. I told you that in general, at this level, we cannot solve that much problems relating in solving differential equations, but this is one of those exceptions, that this is y prime plus a y equals to 0, and here a is a constant. Okay, so let me just review quickly what we did. If you remember, we multiplied both. If we want to find the function y, which fits into this differential equation if a is a given constant, yes? So the method we used was the method of integrating factor. We multiplied both sides by e to the power of ax. Yes? And then we learned that this method invented by a mathematician, of course, it's not a very complicated one, but it might be unusual. Why do you think we need to multiply by e to the power of ax? Someone actually thought about it and came up with this idea. So if you do that, then you will see that this is the derivative of this product. Yes, why is that? If I ask you to differentiate this product, you will tell me that I differentiate the first one and multiply it by the second one itself. But if you differentiate the first one, you really get this one, and you multiply it by y itself. So this will give you the second term here, plus the first one itself multiplied by the derivative of the second one, which you will get the first term. So what I have done is plausible. So someone told me to multiply both sides by this factor, and then when I did that, I realized the left-hand side can be written as a complete derivative and the right-hand side is still 0. And now I am asking you this question, that what is this so that its derivative is 0? So you realize that this is a constant, yes? This is a constant. Okay, and then I am looking for y, so I divide everything by this to make y alone, but usually we bring it up and use the negative power, yes? So this becomes y equals to c e to the power of minus ax. And then, as you expect, this is a first order differential equation. If you want to find the general solution, you need to have one constant free parameter there, and that is your c. And I told you that a is not your free parameter because a is fixed in the beginning. So this, I think you have it in the formula sheet. So for example, if I ask you to solve that equation, I hope that you can see this is very close to what I have written here, except that here, so if you want, I can emphasize that this formula that we derived works only if this constant here is 1. Okay, if that constant is not 1, that's a very simple thing to do, yes? We just divide by 5. So it becomes y prime plus 3 over 5y equals to 0. And now this is playing the role of your a. So then the general solution to this equation is y equals to e as a constant c, e to the power of minus a, which is minus 3 over 5, and then times x. That's general solution. We can double check, by the way, I don't remember in the formula sheet. If in the formula sheet you have this equation, you even don't need to follow anything, so you just use the formula. But of course the question becomes more interested. This is called homogeneous. When the right-hand side is 0, this is called homogeneous differential equation, but it is not very interesting. So it just is very boring. I mean, all the time you just have the equation and you have the formula, okay? It's like ABC formula for quadratic equation. But if I want to make it a little bit more interesting, which in the book you are discussing about that situation as well, is that what happens if on the right-hand side, instead of having a 0, I have a function, okay? That becomes a little bit more interesting. We want to discuss about that today. For example, before doing that, let me give you a very simple example that you can still use the same trick to solve the problem. Okay, so for example, let me change this constant 0 to another constant. So let us change it, for example, y prime. Let me write some number here, for example, minus 5y. And on the right-hand side, if I put 0, you immediately can solve it using the formula. But let us say that I don't put 0, and I put, for example, 3. We want to solve this differential equation. Okay, now can I use the same trick as I used before to solve this equation?
No.
No, don't jump into the conclusion and say no, because you see that if I multiply the left-hand side, if it is not 0, when I multiply the left-hand side by the same factor, it doesn't matter, it still becomes the complete square, but the problem is that the right-hand side doesn't remain so simple. It was 0 before, so when I multiply it by something, it remains 0. But in the case if it is not 0, I am making the right-hand side more complicated, okay? But it doesn't affect the left-hand side. So let us try, because if you are a mathematician, you really don't throw your methods away unless there is a reason to throw them away, yes? So the first thing that comes to my mind, let me see that if the previous trick that I use still is applicable or not. So we just test it. So, but tell me, if you want to use the same trick, what is the integrating factor comes to mind? E to the power of? It was ax, but here a is minus 5, so it becomes e to the power of minus 5x. So I multiply both by e to the power of minus 5x. This becomes y prime. It becomes minus 5e to the power of minus 5x. And on the right-hand side, it becomes 3e to the power of minus 5x. So you see that the left-hand side still can be written as a complete square. A complete derivative. So how can I write that? What is here so that its derivative becomes the whole left side? I missed something here, yes? Yes, I multiply by that, so there is a y left, there is a y here, I forgot to write. Okay, what can I write here?
E to the minus 5y.
E to the power of minus 5x times a y, yes? Let us double check. The derivative of the first one, which is minus 5e to the power of minus 5x, multiplied by the second one, which is exactly the term you see here, plus the first one multiplied by the derivative of the second one, which is exactly the first term. So that's correct. And the right-hand side is there. Okay, so now compare the difference here and there. And still I have the complete derivative on the left, as you see here. But here you guessed what is the question mark by asking yourself, what is that function whose derivative is 0, and you were able to answer a constant. You can ask the same question here, yes? We can ask yourself, what is this function whose derivative is that? So if I want to find the question mark, what is that called? What? What is that called if I want to answer the question? Primitive function. Yes, I want to find a primitive function for this black box because I'm saying that the derivative of this is this one. So what is this one itself? It is a primitive function of that. So what is the primitive function of that? Do you remember or not?
Minus 3 over 5.
And by the way, what I learned in Portugal is that they are following the same, so they don't have the formula sheet available for you, adding pages after pages. They are reducing formulas from the formula sheet when you go to higher grades. Yes? So the formula sheet in Math 5 is the thickest one you get. It contains 8 pages. But there, when you learn something, in the second one, you don't have those formulas in the formula sheet. So you really need to pay attention to your memory, okay? So then what happens here? What is a primitive function for that? Minus 3 over 5 e to the power of minus 5x, but plus a constant, yes? And that's it. And I want to find y. I want to make y alone. So what should I do? I divide everything by this factor, so make y alone. So it becomes y. And when I divide, this term will be cancelled when I divide by that. So minus 3 over 5 is left, plus a constant. And then this constant divided by that. But I bring it up, it becomes e to the power of 5x. Yeah, so that is, can I consider this the general solution of this differential equation? Yes, because it contains one parameter and the order of differential equation is 1. Yes?
Did you mean to write 5 instead of negative 5?
Yes, because I divide. When I divide, c will be divided by e to power minus 5x. Either you keep it in this form, but I prefer to bring it up and make it positive.
Okay.
Yes? That was your question? Okay. So that is actually the general solution. So you see that even though I changed this a little bit, still you can use the same trick. Okay, let us just give you an example, but still you can use the same trick. Okay, so let me write this one. For example, 5y prime plus 2y is equal to e to the power of, let me make it 20. So this I will write it minus 7x. So we want to solve this differential equation. Don't lose the logic what I'm talking about. I am trying to address how we can solve this differential equation for different f of x. I am giving very particular cases that is still the previous method is applicable, even though this is a new lesson. Okay, so what is your suggestion for me?
Start by dividing 5.
By 5, yeah, so divide by 5 everything, so y prime plus 4y becomes 1 over 5 e to the power of minus 7x. And then what I do, I will try to find my integrating factor. So you know that, what is the integrating factor here?
4.
E to the power of 4x, yeah, so I multiply by e to the power of 4x. And then I have to multiply the right-hand side also by e to the power of 4x. But if I ask you, is it still a complete derivative? The answer is yes. I hope that you have enough experience now. So what should I write for this one? 4x times y, yes? You can always double check. The derivative of the first one is this, multiplied by the second one itself. The first one itself multiplied by the derivative of the second one. But you see that again, intentionally, I knew what is going to happen. I gave you a function so that when you multiply, you can compactly write it simpler. So you see, what can I write here now? This is one of those particular cases. E to the power of positive 4x times e to the power of negative 7x minus 3x. So essentially, this problem was different from the previous problem on the board. Yes, because it was 3 here, but this is here e to the power of minus 7x. But after being multiplied, there is no big difference between this one and that one, yes? I have something on the left prime and an exponential function on the right. That's the same thing. Again, if I want to find the question mark, I should ask myself, this is a function whose derivative is this one. So if I want to find this function, what should I do? I need to find the primitive function for this. What's the primitive function for that? It's minus 1 over 15. E to the power of minus 3x plus a constant c. And then what I do, I divide everything by e to the power of 4x. So let us just do it in our head. So let me divide this one first, e to the power of 4x. I bring it up, it becomes e to the power of minus 4x. Okay, but minus 1 over 15. E to the power of minus 3x divided by e to the power of 4x. Which becomes e to the power of negative 7x. So still we can solve it. Yeah? But I don't know if you remember the last lesson, if I change this function to x. Just let me make it very simple. So I multiply it by x. So let me write this differential equation for you. Okay, so if you're a good mathematician, you don't throw your techniques away unless there is a good reason for that. So you still want to do the same thing here. So what do? You multiply both sides by which integrating factor this time? E to the power of x, because a is 1 in this problem. So I multiply it by this. And then the left-hand side can be written as the complete derivative. The right-hand side is still there. And then I ask you, what is the question mark? That is the problem, okay? So then you need to find a primitive function for this. So let me write primitive function of this. But this is not a very simple problem, not hard, but you study it in not high school, you study it in university, okay? But if I succeed to find a primitive function for this, then I can find y, yes? So in principle, that is the problem. Might be you can do some guesswork if you can guess a function whose derivative is this one. I hope that you don't answer this to me, yes? Do you agree this is a primitive function for this, yes or no? This is not a primitive function. The people still believe that this is because they are using this idea. I told you, if you remember, a primitive function of a product and a primitive function of the first one multiplied by primitive function of the second one, unfortunately, is not true. Yes. So if you have the product of two functions, even though you know a primitive function for x is 1/2 x squared, even though you know a primitive function for e to the x is e to the x itself, but there is no guarantee that a primitive function for the product of them is the product of the primitive functions. Okay? So that's the only big problem in front of us. So I just want you to feel why we have to do something. Yes? It's not a big obstacle here. You can solve it if you know how to solve this, but can you guess a function whose derivative is x e to the power of x? It's not that hard, but might be you can do some guesswork to come up with a function whose derivative is x e to the power of x. Any ideas?
With x e to the x minus e to the x.
Yes, thank you. So of course, you cannot rely on the guesswork, because if the function is complicated, even I cannot guess that. So that's not it's good that we solved this particular problem, but in general, I hope that you feel that this still might be a big problem. So let us say I start with x squared, then this becomes x squared. Then guessing a function whose derivative is x squared e to the x just by pure guess is not that easy. But let us check what Aaron said is actually completely correct. Did you say this? Okay, so if I take the derivative of this, what happens? This is E-level question in Math 4. So you want to find a primitive function for this one. So that is the primitive, you want to find the derivative of that one. So this becomes the derivative of the first minus the derivative of the second. But for the derivative of the first, I have to apply the product rule. So this is the derivative of the first function, which is 1 multiplied by the second one, plus the first one multiplied by the derivative of the second one. But the derivative of the second one is the same as itself. So this, what I have written here, is this, and minus, what is the derivative of e to the x? E to the x itself, and what Aaron constructed was correct because these two cancel out, and then what is left is e to the power of ex. So in principle, let me put a question mark here, because it's still, we could solve the problem, but not in general, yes? Because we cannot rely that we will be able to guess. If we can guess, then the problem becomes as before. So instead of that one, I just what Aaron proposed, e to the x e to the power of x minus ex, but plus a constant at the end because you are finding a primitive function, and the problem is finished now. So y becomes, I divide everything by e to the power of x. This becomes x minus this becomes 1, and this becomes c over e to the x, so I write it as this. This is the general solution. So if someone tells you what is the main obstacle in front of you, if you start changing this, nothing, so this is still the method of integrating factor. The idea works, but the problem becomes harder because finding a primitive function on the right-hand side becomes hard. Okay? Okay. So by the way, this method, if we can answer this question mark always, then we don't need to find a new method because that method will work all the time, yes? So let us say I start with this differential equation that we have from the beginning. Okay, I multiply everything by e to power x, e to power ax, the left-hand side becomes this, and the right-hand side becomes this. And then if I want to find that one, then I need to write primitive function of f of x e to the power of ax. So still, in this method of integrating factor, everything works fine, but the problem is that might be finding this primitive function is hard. So it's worth that if we find an alternative method. The alternative method that we will find will not be able to solve all problems, but it can solve important ones. By important ones mean if this function is a polynomial or an exponential or a sine or cosine function or a combination of them, this method that I want to describe today will work. Okay? Okay, so let us try to see what is happening. So I have y prime plus ay equals to f of x, and I want to solve this problem for any given f of x. I could solve it, by the way. That is the general method. So if you go to higher courses in mathematics, you see that is, but of course you know that for some reason your book in the Swedish system, you use integral if you have a and b, but you don't use integral sign for some reason if you don't have that a and b. So this is called definite integral. That's exactly the integral that you're familiar with in Math 4. But this is the symbol that in higher level books they use for the notion of primitive. So when you write, for example, instead of asking you find a primitive function for x in English sentence, in math books you might see this. That's the same thing. They are asking what are primitive functions for x. So the answer to this is 1 over x squared, but plus a constant c. Okay? So let us learn this. This is not a big problem, yes? So this is, because this is, there, I can understand why in Swedish system they are avoiding this, because in principle there is no connection between these two. The reason that they are connected, the notion of primitive function get connected to the integral because of Newton's formula. You remember? Because I told you, if you remember when I started talking about primitive functions, I told you that just assume it as a mathematical curiosity, just as a game. Why it becomes important? Because Newton found the connection between the notion of an integral and the notion of derivative and primitive functions. Okay, so if you go to higher math books, you have these two symbols. One is, as exactly you know in Math 4, that's called an integral. But because we will have two types of integrals, this is called a definite integral, yes? And this is called an indefinite integral, yes? Okay. But if someone asks you what is a definite integral, exactly as the integral without this adjective, and if someone asks what is the meaning of an indefinite integrals is something that sits instead of saying primitive function. Yes? So for example, if I ask you what is calculate or compute the following integral, I can say that, but what do I mean by that? As soon as you see this symbol without these limits, you understand that even though we use the word integral again, but we mean primitive function. So what's the primitive function for cosine 5x? It is 1 over 5 sine 5x, and of course you add a constant to it. Okay? And programs are very good in calculating this. So I think even in GeoGebra you have this symbol. I don't remember exactly, but I think you have it. So remember, that is the role of this symbol is to produce you all primitive functions of your function. So if I want to solve this using this idea, so you can multiply everything by e to the power of ax, so it becomes e to the power of ax y prime plus e to the power of ax a y is equal to e to the power of ax f of x, and then you collect the left-hand side and the right-hand side like this, and then you ask yourself what is a primitive function. Then you know that e to the power of ax y in the language that I described right now, it becomes the integral of this combination. Okay, and then I put a constant c here. And then I divide everything by e to the power ax. So y becomes e to the power of minus ax integral e to the power of ax f of x dx plus c e to the power of minus ax. Okay, so if you go a little bit higher level, you see that they give you this formula for solving this differential equation. Okay, for example, if I go back to this problem of, let us say that f of x is x. You remember this f of x here. Let us choose f of x to be x. Here a is 1. So if I give you this differential equation, and if you have this formula in front of you, you can plug the numbers in, yes? So what happens, y becomes equal to e to the power of a in that problem is 1, and then integral, this becomes e to the power of x. In this problem, f of x is x, and then I have dx plus c e to the power of minus x. So this is acceptable, by the way, okay? Sometimes this integral can be calculated, and sometimes it cannot be calculated, even if you have, if you're a brilliant mathematician. For example, don't think that I told you before, if you tell me what is a primitive function of e to the power of x squared, I will not be able to answer that using the functions we know. It means that among the polynomial functions, trigonometric functions, exponential functions, logarithmic functions, these are the functions that we know. You cannot construct any function of this type whose derivative is simply e to the power of x squared. There are functions whose derivatives are that, and that is called the error function. So you can construct a function whose derivative is this. So what I'm trying to say is that if you have this formula, it is valuable. If your goal is just without understanding, find the formula, the answer. You put this in a computer program, and if this is one of those functions that the computer can calculate its primitive function, then you have your answer. Okay? By the way, that's a good idea if I check at this point if GeoGebra is also doing that. So GeoGebra, we need to go to cast view to see it. You see this symbol is also there. So this is just the primitive function symbol. So for example, if I want to solve that problem, I don't know how to do it, but let me see. Do you know how to, in GeoGebra, I put x, and then multiplication. Let me use e, this e is here, e to the power of x. Yes, a to the power of x. So, okay, I don't know if I press here, I will get the answer. Yes, so that's the answer. And that's exactly that Aaron actually guessed, but of course in factorized form. So if you multiply e to the x in, it becomes e to the power of x times x minus e to the power of x. So that's why I'm saying, if I go back to the board again, so you see that this formula is completely useful. If your goal is just to find the answer, exactly like ABC formula, after you understood what is ABC formula, you don't always prove the formula over and over again. Okay, but here, this is also the same thing. So if I have this formula, I put my A, I put my f of x into this formula, and let us say that you are good in calculating this or you have this application available, then you have your answer. Okay, so this means that we really solve this problem in its full generality. Okay? Is that understandable? But even for me, calculating this integral by hand might be sometimes hard or sometimes even impossible. Okay? There is an alternative method that your book has decided to talk about that, and that is the case. So this is I want you to understand the logic. F of x be a polynomial or an exponential a sine or cosine function, sine, cosine function, or a combination of them. Okay? Wait, just 1 minute. So I just want you to understand, you see that in principle I don't need to have divisions because for all cases I will be able to find a formula. Okay? But for 3 types of functions, polynomial, exponential, and sine or cosine, or combination of them, we have an alternative. That I want to describe that alternative. Yes?
Can I ask you, how do you detect error functions? You said error.
No, error not, don't get confused. Error function is not what you see as error. It appears in some kind of probability theory regarding measuring errors. But that is a new function. So we artifact a function whose derivative is this one. But this function is not a function among polynomials, exponentials, so it doesn't matter. If you sit down and try to do what Aaron did for that simple function, for this function, the functions that you are familiar with are polynomial, exponential, trigonometric, logarithmic, and these functions. You will not be able to construct any function with these functions whose derivative turns out to be this. But the question is that, is there any function whose derivative is equal to this? Yes, the answer is yes, but what function? A function you have to artifact in that way. Okay, so now the lesson will be, probably this session and the next session, we'll be talking a little bit about these ideas, okay? The method that we want to describe is the method of undetermined coefficient, okay? The method of undetermined coefficients. This I want to describe a little bit later, either today or the next session, okay? So I want you to don't lose the logic. So we were able to solve this problem in its full generality, but for particular cases of f that you see on the board, we have an alternative method, which is called the undetermined coefficients. But before doing that, I need to pave the way so that you can understand this. So have it in the back of your head. We have to return back to this problem again, okay? Okay, so what we do, I want to talk a little bit about the theory of differential equations, which is also in the book, okay? So if I have y prime a y equals to 0, and then I have y prime plus a y equals to f of x. The terminology I want you to learn, this is the one that you have 0 on the right, is called homogeneous. Or I think in Canada they call it
Homogeneous.
homogeneous, yes, yeah. And then anyway, but here you can, this is called non-homogeneous. Let us just stick to the American one. What is the British pronunciation, do you know?
Homogeneous.
It's also homogeneous, yes? So I think that Canada should follow the US, yes? They're betraying US, yes? They're their neighbors, okay. Anyway. Yeah. Anyway, so we want to, this one we already solved in general. So we don't have any problems with that. So why, you might say why I am bringing it up again. Because we learned that the general solution, and then I put an index h here to show that this is the solution to this homogeneous one, okay? So c e to the power of minus x. Okay, my claim is that my goal is to find the general solution. This is my goal. I want to answer this. The claim is this. The claim is that the question mark that you are looking for, so let me write y for it, is equal to y homogeneous, it means this y, plus y I equate it with the subscript p, this is y particular. So let me write the claim. I'm claiming that the general solution of this differential equation can be written as the sum of two parts. One part is the solution to the one on which the in which the right hand side is 0, the homogeneous one, plus a particular solution of this differential equation, not the general. To find the general solution of this, you don't need to solve this in full generality, you just need to find a particular solution. Whatever that particular solution is, you add it to the general solution of the homogeneous part, it becomes a solution. My claim is that what you get is the general solution of this differential equation that you want. Okay? So let me write, what is this? This is exactly this one, the general solution to y prime plus ay equals to 0. This is a particular, let me emphasize, a particular solution to y prime plus ay equals to f of x. This is still not being proven. I'm just giving you the news, okay? But we want to show that this is indeed the case. If I want to explain it once more, I give you this differential equation, which is the non-homogeneous one. If f of x is not 0, my goal is to find the general solution. Here, I am claiming that instead of finding the general solution to this, you can go and find the general solution of this one, which is exactly the same one, unless the right-hand side is just 0, the corresponding homogeneous one. Yes? Okay, so, and then you just find a particular solution to differential equation and add them up. What you get is the general solution of this differential equation that you're looking for. That's the claim. Okay, why do you think it's true? If I want to show that this is the general solution of this one, can you tell me what should I show? So you see, my claim is that this combination is the general solution of this equation. I have two tasks to do. One task is to show what? This is simple. I tell you that 2x minus 4 equals to 0, x2 is a solution. What do? Either you solve the equation, you find 2, or if you cannot solve the equation, but still you can confirm that this is an answer. How? By inserting. So here, this is one of those cases that I am claiming this is a solution. I want to show that yes, it is really a solution. So I have to insert it and show that it works. Okay, so let us try. What we want to show that this is a solution to this differential equation. So what does it mean? Instead of y, I take it off and then put this in. And I start from left-hand side, hopefully I can reach the right-hand side. Okay, so let us start. So the left-hand side is equal to, instead of y, I put y sub h plus y sub p prime. Yes? Plus a times y, but y is still the same. Yes? And I want to simplify that with the hope that I can reach to f of x, which is the right-hand side. Okay, but I want your help. So what do you think I will do now? I am claiming this is the general solution. Forget about this adjective for the time being. Just concentrate on being a solution. I'm claiming this is a solution. To prove my claim, I have to show that if I insert it here, it works. So what should I do? I inserted that, and I want you to help me to continue. What's the next step? Yeah?
Multiply by e to the power
No. You don't need to that, because you're not solving. The solution is already proposed to you. I told you that if the solution is proposed to you, if you want to confirm that, you just insert that and do the calculation. So here, if I ask you to confirm that, you just replace x with 2, you write the left-hand side is equal to, instead of x you put 2 and then minus 4, and then you calculate this one, it becomes 4 minus 4 minus 4 is 0, and then it becomes the right-hand side. So you confirm that this given is an answer. Yes? So here I did the same thing. Okay? By the way, don't say that, because if you say that I multiply by e to the power of ax, you have to multiply both sides. Which sides? You mean LHS, this LHS by e to power x. It doesn't work, okay? So let's just continue. So I have to calculate now. So what do you do? Yes?
for a.
No, there. What is the next thing I want to write here?
You multiply a,
Okay, one of them, and then?
and then you put in the.
No, this what I expect you. Okay, so you said that I multiply. Let me just do that. So I agree with this one. But don't you want to do something here?
Then instead of YH, put the constant you have for C.
No, but I agree with you. But don't you want to do something here? YH plus Y prime. Yes?
You have to find the primitive function of each of them. So you have, or the first one is.
No, don't drive me mad, okay? So, you want to continue, what do you write in front? Yes? Hussein said one of them. He said that I multiply A, I agree. Yes?
You separate the derivatives.
Yes, it is the derivative of the sum. It becomes the derivative of the first one. These things are important, I'm asking you. If you want to be good in math, you need to ask yourself why I didn't come up with this idea myself. Every time you have to correct something in your brain. Is that understandable? Yes? I want to simplify things. So I want to simplify. Now I am ready to hear from you. Okay, so that you are jumping the steps, yes? Okay, so what do? You don't need to make use of this. You can do that, but you are making life harder for yourself. Okay? But how can I do that? Any ideas? I want to have it in two parentheses. Can you tell me how? What is the natural way to do it?
Maybe you put the homogeneous in one and the particular in one.
Yeah. It's not hard. I just want you to see, I want you to learn these things are not hard, yes? Y prime P plus A Y P. Yes? But why do you think I did that? Because I can immediately answer this. What is this? You don't need to put this in. If you put this in and do the calculations, it works, but don't do that. What is the answer to this?
0.
0. Why?
Because
I am telling you this is a solution to this. If this one is a solution of this, it means that if you replace y with that y sub h, it becomes 0. Of course, if you put this and do the calculation, it becomes 0, but you don't need that. It is 0. Yes? But can you tell me for the same reason what is the next one? f of x, why? Because you see, what is y sub p? A particular solution of this differential equation. What does it mean? It means that if I replace y with the given solution, it works. Yes, it becomes the f of x. So this is 0, this is f of x. And then it becomes f of x, and this is become, so it's actually nothing. Just writing, yes? But it needs to be written. You cannot say it is trivial. Yes, it is, it's not trivial. It is simple, but not trivial. You have to say, I started from the left-hand side. I inserted this claimed answer in there, and I was able to show that the left-hand side becomes the right-hand side if I replace y with the claimed answer, yes? Is that clear or not? Yes or no? Okay, but I want to claim a little bit more. My claim was not that this is a solution. My claim was that this is the general solution to this. Yes? So far, I showed that this is a solution. Why do you think that this is now the general solution? Why do you think that if I do this, I will get not only a solution, but the general solution? Let me teach you mathematics. What do you think? What are you thinking about? When I ask you to show that this is the general solution, immediately you need to train your brain to refer to what? One word. Yes?
No, I don't know the one word.
No, one word. Because you need to train your brain like this if you want. When I say that I want you to prove the general solution, we prove the solution part, we want to emphasize on the word general. I want to claim, I want to prove that this is not only a solution, but the general solution. So what do you refer to in your brain? Because that is makes your life hard in mathematics. What do you refer to? Say something. It's not possible that you don't say something. We are talking about the general solution over and over again. Don't you have any clue about what is the general? Yes? One word?
Order.
Pardon?
Order.
No. I understand what you mean. No, but what do you refer to? Where do you think that why order matters? Yeah, you are. If I give you time, you can explain it, and I am sure that you are right. Yes? Might be I'm confusing you, but I'm not, yes? You are confused because you're not thinking in a mathematical way. So if you want to show that this is the general solution, you need to refer to the definition. So what is the meaning of the general solution? You want to show that this is the general solution. We have some agreement about what is the meaning of the word the general solution. So you need to show that, okay, if I want to claim this, I need to think in this way. What I am supposed to do in order to prove this is the general solution? I need to confirm that it fits the definition of the general solution. That's what it is, yes? Is that understandable or not? You want to prove that this is the general solution. I want to show that this is a solution. You put it in. Why? Because that is the meaning of a solution. That is the definition of a solution. So whenever you want to prove that this is the general solution, you have to refer to the definition of the general solution. Okay? So it needs a little bit of memory. So what is the definition of the general solution? Two criteria. One. No. The general solution is such that the general solution is a solution such that it contains as many free parameters as the order of the differential equation. I am sure that you knew it, but the reason that you were not able to say it, you need to fix it in your brain yourself. And my role as a teacher is just draw your attention to it. And if you learn how to do it, then you will learn. Okay, so anyway, now can you prove it for me? If I want to prove that what I claim here is the general solution, yes, I need to show two things. I need to show that this is a solution, which I accomplished here. I need to show that it contains as many free parameters as the order of my differential equation. Yes? So then the question is that, what is the order of differential equation?
First.
It's a first order. You see, again, you are using the definition of the order. Okay? So because this is the first order. So I need to show that this contains exactly one free parameter. Do you agree with that or not? If yes, why? Why do you think it contains one free parameter? The free parameter is not being detected directly. But I'm claiming that inside this, there is exactly one free parameter left for you. Why is that?
Because YH is...
YH contains your free parameter. That's it. So there is nothing. It's just playing a game. Yes? You see that sometimes philosophers sit down and think you were saying that they are talking nonsense, but this is sensible. It was nothing actually. This was just following the definitions one after the other. Okay, so this is the general solution because this is a particular solution, so it does not contain any free parameters. This is the general solution of that one, but it contains one free parameter. But who cares? The free parameter that you see here serves as the free parameter of the whole combination. Yes, that's what we're done. Yes? Yes, Rocco? Can you see me? No. So anyway, so this is the theory part. If you want to be good in mathematics, you should be able to care about the theory parts. Very important, okay? But anyway, you can forget everything and follow the algorithm. So the algorithm tells you that if you want to find the general solution of that, if you succeed to find a particular solution of that, and because we have already solved this problem in its generality, we just add these two and then you are done. Okay? Yes or no? Okay, so now we go back to what we started, yes? So now my problem of solving this reduces to finding this. Because there is no way that I can miss this. I found this formula. Okay? So you see that in order to find a general solution here, I need to find this, I need to find that. I already know it, so I don't need to find it. I'm not worried about this part. The only part that I'm worried about is to find a particular solution. And for the particular solution, I want to say that what happens if you have f of x one of these three cases, okay? Okay, let me start the lesson at least, and then might be we can continue later. So if I give you this equation, this differential equation, let me solve the same thing that I started with. Do you remember? I think it was something like this. We had it somewhere. If you refer to your notebooks, you will see that we will have it. Okay. So now I want to solve this differential equation. Let me review everything from scratch. So you see this differential equation, this is your duty. You need to understand this is this lesson. Yes? It's not hard to understand. For this one, we have a method which is integrating factor method, but usually it becomes very hard for you if you don't know how to calculate this a little bit complicated integral. Okay? But you remember this lesson tells you that if on the right-hand side you have three types of functions, polynomial, exponential, sine, and cosine, you can use an alternative technique to solve the problem. Alternative technique is called the undetermined coefficients. Is this one of those is this one of those cases that I can use this alternative method? Yes, because f of x is x is a polynomial function. So I can use this method that I'm going to describe to solve that one. But how do you solve the problem? In your head, you divide the problem into two problems. Yes, one problem is just the homogeneous one, and you solve it in its full generality. What is that? It is a constant c e to the power of minus ax, which is minus x. This is the YH part. So this is done. Now I want to find YP part. This is the new lesson. For YP part, you need to guess. This method of undetermined coefficients is a combination, is a hybrid of guesswork and not guessing. Yes, a little bit of that. I am looking for a function that fits into this equation. Do you think it is reasonable to look for exponential functions fitting this equation?
No.
No, because if you say y is an exponential, its derivative is also an exponential. And if I add these two exponential functions, there is no way for me to get a polynomial function. So why even I should bother about exponential functions? Do you think it's a good idea to look, because by the way, in this problem you don't look for all of them. You just need one of them that works. Because I need one particular solution, not all of them. That is the power of this method. So you just need to find one solution that works. Then you are done. But I am telling you there is no reason to look for sine and cosine functions here. Because the derivative of sine and cosine function is again sine and cosine. And if you combine sine and cosine, there is no way that you can get x out of it. So there is no way to go for finding, to look for sine and cosine functions. So what is another thing come to my mind? What type of function do you expect that it has a higher chance to find some solution among them? Polynomial function. But let me ask you another question. Because when you say polynomial functions, how many polynomials are there? Infinitely many. Do you think there is a good way, do you think it is reasonable to look among third-degree polynomials? No, because if I have a third-degree polynomial, y is a third-degree polynomial, y prime is second degree, and if I have a third degree, second degree, add them, there is no way for me to get a first degree polynomial. Is that understandable? So so you see, you will realize that you don't need to look for all possible functions because you just need one, and there is no reason to look for sine, cosine, exponential functions. The most reasonable one is among polynomials, and among polynomials, which polynomials are probably the best option we have, the best chance we have? First degree. Yes, because if you have a first degree polynomial, its derivative becomes a number, and you have a first degree polynomial plus a number which becomes a first degree polynomial. So my chance is increased. Yes, but how many first degree polynomials are there? Infinitely many. So that is a little bit guesswork. So the guesswork took me up to here. Okay, let me change these letters. That you are not confused. Let me write, I don't know, M and H, okay? So this is my guess for the time being for YP. But still, this is, I told you, a hybrid of guesswork and analytic work. This was the guess part. So you ruled out all other possibilities, you come up with this possibility only, but still how many unknowns are left for you to determine? 2. Okay, so this one, these are coefficients and not determined yet. So this is why we call it undetermined coefficients. Yes? So I need to find these coefficients. How can I do that? Just tell me again. But don't drive me mad, yes? I want to find M and H. What should I do? Okay, let us, by the way, make it M and N, because it becomes more sweet, yes? Let us find M and N. The chocolate brand, yes? So, how do you find M&M? Not in the shops, yes. Of course, one way of finding M&M is going to Eco and find some M&M. But here, how do you think I will solve the problem? Yes?
You insert it in.
Exactly, because you are telling me that this is supposed to be a solution. If it is supposed to be a solution, what is the meaning? It has to fit into the equation. Yes? So this means that I replace y with that combination. So mx plus n prime plus y, which is mx plus n, equals to x. This one is...
You've already solved the first one.
That the general one we solved. I'm just looking for this one. Don't put it 0, because this is for the non-homogeneous one. And then I try to simplify both sides. The left-hand side becomes what? M. The right-hand side, this one is just mx plus n and the right hand side is x, and then I replace them mx, write them a little bit in or organized way x. Okay? Remember, you don't want to find all possible solutions. You just need one particular solution. Okay? So this means that can you fine tune m and n in a way that the left hand side becomes equal to the right hand side? Extremely easy, yes? What should I do? I find a system. The coefficient of x here is m. I want to have it 1. So m is 1. The constant number on the left is 0. The constant number on the left is m plus n. The constant number on the right is 0. I want to fit them. So this is the solution that I get. And this is extremely simple problem to solve. N is minus m, so it's minus. Yes, and then what can you tell me about the particular solution? My particular solution is x minus 1. This is my particular solution. But now, help me to solve the general solution. So, you write the general solution of your differential equation. Y is equal to what?
C minus x.
Yes, because I removed that. It was YH plus YP. YH, it's on the board. C e to the power of minus x plus YP, which is x minus 1. And I hope that you have still the solution to this in your notebook. You can compare that the solutions are the same. Okay, I will stop here because it was too much information, I think. But we will practice a bit about this a little bit more. Not a little more. I'll just give you more examples, okay? So, by the way, for this simple one, because I have already this in my memory, I might prefer to do this. But for example, if you increase this polynomial to x squared plus 3x plus 5, for example, I myself prefer to use undetermined coefficient, even though I don't have any problems with calculating primitive functions. So that's what I'm saying, that even if you have enough practice in calculating this, but for some cases, still the second method is more convenient to work out. Okay, so this is the lesson, the whole lesson, but we will of course practice a lot more about solving these differential equations. I haven't given you an example of exponential functions. I will give you sine, cosine, a little bit more interesting problems. Okay, any questions?
Can you have some problems that you solve?
Pardon?
A few problems we can put together.
I will bring that. Yes. Any questions? Thank you very much.